Hi, this is Mrs. Bustamante. Today we're going to talk about Dalton's law of partial pressures. And basically what Dalton's law of partial pressures tells us is that we can take multiple gas molecules in a system, and if we know the individual pressures of them, we can add them together to give us our total pressure. So if we look over here right now, we have these light red particles in there. They're at a temperature of 300 Kelvin, and the volume that they're in is fixed. And we notice the pressure is 11.7 atmospheres, or about 12. So I'm going to go ahead, I'm going to add some of these blue particles, and we'll give our system just a moment to equalize, to become kind of spread out and how it would normally behave. And when we do that, now that we added those particles, we notice that the pressure of the system is 17.5 atmospheres. So it's gone up, which we would expect as we added more particles in there. And it's gone up, what'd you say, about 6-ish or so, a little less than 6, right? When we compare it to what the pressure of just our red particles was. And we can see that they're moving and they're colliding with each other. And then I'm going to take out the red particles so I can just see the pressure of the blue gas particles. And look, it's about 5.8 atmospheres, about 6, just like we said it should be based on Dalton's law. So let's talk about what that would look like in an equation form, right? Dalton's law would tell us that the total pressure of a system would be equal to P1 plus P2 plus P3 plus P4, however many just different types of gases you have. That's why we have N. It just means any number of them, you add them together. And P, of course, stands for pressure. It'll work in any type of units. So you just want to make sure that you keep your units consistent of all your different gases that you're looking at. So what might be a type of problem you see? Okay, you might see a problem that looks something like this. Air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen at 101.3 kilopascals if the pressure of nitrogen is 79.10 kPa, carbon dioxide is 0.40 kPa, and the other gases equal 0.94 kPa? Well, we know the pressure of nitrogen, they told us, was 79.1 kPa. We know the pressure of carbon dioxide was 0.04 kPa. And we know that the pressure of the other gases was 0.9 kPa. And we know that we're looking for the pressure of oxygen. But there's one other piece of information they give us. They tell us that we're at a total pressure of 101.3 kilopascals. That's all of them added together. So in this problem, we know that our total pressure is 101.3 kPa. And here's our equation, right? We have 4 different gases, so the pressure of those 4 gases will equal our total pressure. And now we just plug in the information we were given. 101.3 kPa equals 79.1 kPa plus 0.040 kPa plus 0.94 kPa plus the pressure of oxygen. I add all these numbers together. I get 80.08 kPa plus the pressure of my oxygen. I subtract that 80.08 kPa from the right side, and if I do it to the right side, I must golden rule it and do it to the left side as well. And that gives me that the pressure of my oxygen gas is 20.5 kilopascals.